Is God really everywhere? Or does God not exist at all? And what would one of the greatest physicists who ever lived, Richard Feynman, say about a question this big? Before we begin, let's meet the man. Richard Feynman was an American theoretical physicist, a Nobel Prize winner, and one of the architects of quantum electrodynamics. He was famous for explaining the deepest ideas with stunning simplicity, and he had a remarkable way of looking at the universe, a way that often touched on the biggest questions of all. The question we're asking today is ancient. Is God present everywhere, woven into the fabric of reality? Or is the universe simply a vast machine of particles and forces where the idea of God has no place at all? Today we'll gently explore what modern physics, in Feynman's own words, suggest about this profound mystery. Before we ask whether God is everywhere, we need to ask what everywhere actually means in physics. To a physicist, space is not just empty distance. It's a stage filled with invisible structures, called fields, that stretch across the whole universe. According to modern physics, every particle you've ever heard of, electrons, photons, quarks, is really just a ripple in a deeper, invisible thing called a quantum field. These fields fill all of space. There's an electron field, a photon field, a Higgs field. Wherever you look, in every cubic millimeter of the cosmos, these fields are present. So in a sense, something is everywhere. This is one of the strangest discoveries of 20th century physics. The vacuum of space is not nothing. It's a humming, vibrating sea of possibility, where tiny particles can pop in and out of existence. The universe, at its deepest level, is full, not empty. So if these fields are everywhere, does that make them divine? Are we accidentally describing God in the language of mathematics? Well, that's a beautiful poetic thought, but a physicist would say no. The Higgs field doesn't love you. The electron field doesn't answer prayers. These fields are mathematical descriptions of how nature behaves, not conscious beings. They are everywhere, but they are not aware. That's an important distinction. So what did Feynman himself believe? Feynman was raised in a Jewish family, but he was openly skeptical of organized religion. He wasn't comfortable claiming there is no God, and he wasn't comfortable claiming there is one. He preferred to live in the uncertainty. In his own way, he often said, it's far better to live not knowing than to have answers that might be wrong. He valued doubt, not as a weakness, but as a kind of intellectual honesty. Feynman often said something quite humble for such a brilliant mind. He said he didn't have to know an answer. He was not afraid of being unsure. This idea, that not knowing is okay, is at the very heart of how science actually works. Now, there's a famous idea in the science and religion debate called the God of the gaps. It goes like this. Whenever science can't yet explain something, the origin of the universe, the rise of consciousness, the nature of time, some people fill that gap with God. Feynman was deeply uneasy with this. To him, putting God in the gaps was a kind of intellectual surrender because the gaps tend to shrink as our understanding grows. Think about it this way. 100 years ago, lightning was mysterious. 200 years ago, disease seemed almost magical. Each time we learned more and the so-called divine explanation got smaller. Feynman believed the honest answer is often simply, we don't know yet. But here's the thing. Even without traditional belief, Feynman was overflowing with wonder. He spoke about the beauty of a flower, the structure of atoms, the dance of galaxies in language that almost sounded religious. He felt that the imagination of nature is far greater than the imagination of any human being. For Feynman, awe didn't require a god. Awe was already everywhere in the quiet patterns of reality. This is one of his most powerful ideas. Doubt, he said, is essential. Without doubt, science cannot progress. Without doubt, we just hold on to whatever stories we were told as children. To question, to test, to be willing to be wrong, that to Feynman was the deepest form of respect for the truth. Some thinkers describe science and religion as two different ways of knowing. Science tells us how things work. Religion, in many traditions, tries to tell us why we are here and how we should live. These are different kinds of questions. Feynman was respectful of meaning and morality, but he didn't think you needed religion to find them. Many people, of course, would strongly disagree, and that's part of what makes this conversation so rich. Religion, throughout human history, has been concerned with meaning, with community, with morality, and with the experience of the sacred. It deals with questions that often go beyond what an equation can capture. For billions of people, this is the deepest source of comfort and direction. Science, on the other hand, deals with what can be measured, tested, and predicted. It tells us how stars are born, how cells divide, how black holes bend light. But science doesn't tell us what is morally right or why anything exists at all. It quietly admits the limits of its own reach. So can science and religion live side by side? Many scientists say yes, they study the universe by day and pray, meditate, or reflect by night. Others say no. They believe the two worldviews ultimately clash. Feynman himself simply walked his own path of curiosity and honest doubt. Step back for a moment and consider the cosmos. There are more stars in the observable universe than grains of sand on every beach on Earth. Around many of those stars, planets are spinning, possibly carrying life. And inside you, right now, are particles forged in the cores of dying stars. Some call this divine design. Others call it the magnificent result of physical law. Feynman would say, either way, it's extraordinary and worthy of awe. Every atom in your body that isn't hydrogen was once cooked inside a star. You are made of the universe looking back at itself. Whether you see this as the work of a creator or as the elegant outcome of physics, it is one of the most remarkable facts ever discovered. Let's return to one of the deepest weirdnesses of physics. Even in the emptiest patch of space where no atoms exist, the vacuum is alive. Quantum theory tells us that pairs of virtual particles are constantly appearing and disappearing in this so-called nothingness. It's as though the universe never truly rests. Some find a kind of cosmic mystery in this. Others see only mathematics. Both are honest responses to a deeply strange reality. These tiny fluctuations are not science fiction. They have real, measurable effects. They influence the behavior of atoms, the energy of empty space, and possibly even the structure of the early universe. The universe, it seems, is full of activity at every level, even when it appears to be still. Here's something Feynman openly admitted. Physics is full of unanswered questions. We don't fully understand why the laws of nature take the form they do. We don't know exactly why the universe began. We don't know if consciousness is purely physical or something stranger. These mysteries don't prove that God exists, but they remind us that the universe is far from a closed, finished story. There's still room for wonder. Feynman called this feeling the pleasure of finding things out. For him, the joy of science was not in having all the answers. It was in the search itself, peeling back layer after layer of nature's secrets. Each new discovery opened a door to even deeper questions. That, to him, was the real treasure. You might wonder why any of this matters in your daily life. Well, the way we answer these questions shapes how we treat each other, how we make decisions, how we face suffering, and how we find meaning. Whether you lean toward belief, doubt, or somewhere in between, taking these questions seriously is part of being a thoughtful human being. Now, here's a personal note. This video isn't here to tell you what to believe. It's here to invite you to think. Feynman himself never wanted disciples. He wanted curious minds, people willing to ask hard questions, accept honest answers, and stay open to wonder wherever it leads. And here's a key point. Physics by itself cannot prove or disprove the existence of God. It simply describes the patterns of nature. The question of God lies beyond the reach of any equation. Some scientists are believers, some are not, and most quietly hold their views with humility. Science is incredibly powerful, but it has limits. It can map the cosmos, but it cannot weigh meaning. It can describe how an atom behaves, but not how grief feels. Recognizing these limits isn't a weakness of science. It's a sign of its honesty. Today, physicists are still grappling with deep, open questions. What happened before the Big Bang? What is dark matter, really? Why does the universe seem so finely tuned for life? These are not solved problems. They are invitations to think and possibly one day to know more. Richard Feynman passed away in 1988, but his ideas remain alive in every physics classroom in the world. His diagrams, his lectures, his curiosity, they shaped generations. And perhaps his greatest legacy was this simple lesson. It's okay not to know. It's okay to question. It's okay to be in awe of a universe that may always hold one more secret. That openness, that humility is the real gift of science. There is a quiet beauty in uncertainty. It keeps the mind humble. It keeps the heart open. Whether or not God is everywhere, the universe certainly is. Endlessly strange, endlessly deep, and endlessly worth exploring. So is God really everywhere, or does God not exist? Feynman would probably smile, shrug, and tell you the honest answer. He didn't know, and he was at peace with that. Maybe the real wisdom isn't in choosing a side, but in learning to live thoughtfully with the question itself. If you enjoyed this exploration, please hit that like button, share your respectful thoughts in the comments below, and subscribe for more deep dives into the physics that shapes our world.